Good day. We will conduct a brief item analysis of the Module 3 assessment first attempt. All of our students performed an attempt. Although some students rushed, you could tell that there was 45 minutes, nowhere near the 45 minutes were taken up to log the first attempt. The average score was a 2.82. So it's a little below a 60 average. The rubric determined that 15 of 18 questions were considered medium questions in terms of difficulty, 3 hard questions and 1 easy question. But as far as discrimination was concerned, we had a fair range of results. There were a few questions where students answered nearly everything correctly and answered in the same fashion, so these were considered poor questions. We'll begin with the items that pose the greatest challenge, and we'll work our way down. I guess the only one we won't take up would be our matching at the end. So our first question, multiple choice, reads, in contrast to IPv4, IPv6 offers significant improvements for IP networks. However, a leading concern related to implementation has been noted. Which statement best reflects the issue? Network security can be an issue when existing IPv4 networks are mixed with the IPv6 networks. That's because Toretto and ATAPI and ISOTAP, these are tunneling protocols. They've been known to introduce some network exposures. So that is the correct answer. Many said that IPv6 networks do not use DHCP and lack the means to automate client address assignments. That is incorrect. It basically uses an automatic address assignment algorithm. It just doesn't use DHCP, so that's something to keep in mind. Our second question reads, which adaptation? You are tasked to resolve a resource challenge. The local internet service provider has fewer IPv4 public addresses for customers. You must set up web, email, and DNS systems for a client who desires to operate their own servers locally for this purpose. The systems must run in a private, highly filtered or screened subnet. We're talking about a DMZ, apart from the users at the site. Which adaptation do you use to conserve the few public addresses remaining? You're going to want to use static NAT. That's because these special purpose servers, web, email, and DNS, are going to require a static IP address, a static network address. And because you're putting them in a DMZ, they're going to have a private internal address, so there will be a one-to-one mapping between the public and the private. That's what we do typically. SuperNet versus Cider. You are hired, SuperNet via Cider, you are hired to restructure the public network address allocated by a smaller local ISP to improve efficiency by merging 2 adjacent /17 networks. Well, if you have a pair of /17s and you merge 2 of them, you're basically doubling the address range. That means you're sliding the subnet mask 1 place to the left, which makes it a /16. Well, that eliminates 2 of the incorrect answers, and that leaves us down to one of these 2. Let's read the rest. You want to create a larger network with a single contiguous address range, an existing IP address 146.226.234.23 with an existing subnet mask of 255.255.128.0. That's the /17. That's what that is. in dotted decimal format, must remain a part of the original network and the new network. What are we saying? This address has to be a part of the new network. You decide to use the Cider method to create the new network. When you slide one place to the left, ordinarily the network ID for this existing or previously existing network would be 146.226.128.0. If you basically look at it, you can take a look at the jody.de website. There's a link for it in your study guide. It allows you to put this stuff in there. If you use that link, you can basically punch these numbers in and it gives you this information right here. The gateway is this address. You want to choose the network ID and the gateway address. IPv6 access to resources, part B. So there's a couple of questions about IPv6 access to resources. You are a programmer who must update your code to ensure that network resources can be accessed using the new IPv6 address. Network resources are mapped for access using the legacy practice of connection known as the Uniform Naming Convention. That's a // and then either a name or an IP address. And then there's like a network share. It would be a directory called workgroup, and it's hidden. That's what the $sign means. How must you format the new IPv6 address for such resource maps across the network? Well, if you're using IPv6, you're going to substitute you're going to use, instead of using the colons, you're going to use a dash. And then you're going to put a .ipv6-literal.net on the end of it. That's how you would use UNC with IPv6. And then basically if you're using HTTP and you want to use a URL, that's where you use square brackets. So we're not using HTTP when we're doing UNC. It's a different format. This multiple choice reads, it's about a larger IP class assignment. A company informs the internet service provider that it needs twice as many public IP addresses than the existing Class C address range provides. While a Class C address range provides 256 total addresses, 3 are taken up, one by the network identity, one by the gateway address, and one by the broadcast address. So there's 253 usable addresses. The ISP, they need twice as many of that, so that means they need about 500. The ISP informs the company they can upgrade to a Class B address range at no additional cost. What is the greatest disadvantage of using this method to resolve this need? Choose the best answer statement from the one below. Well, if you move from a Class C to a Class B, you need about 500 addresses, but a Class B provides 65,536, which means we would waste too many unused public addresses. It's terrible, and it's what they used to do all the time before Cider came along. Cider Solution B. So you are providing the following IP address. You are provided with the following IP address and subnet mask for a network host on a public network: 27.143.22.147/24. For all sorts of reasons, the existing IP address cannot be changed. That means it needs to remain a static address on a particular host. probably a server or a special resource. The existing network must be segregated into smaller subnets for better security using a Cider solution. Currently, 250 hosts share the same subnet. The number of network hosts will be reduced so that 30 hosts will share the same network environment. So we had a /24. If we cut it in half and go to a /25, we have 128 total addresses. A /26, 64. A /27 involves 32 addresses, 30 hosts. That's what we're talking about. However, there are plans to accommodate new growth. So instead of just having 30, if there's going to be new growth, you should plan for about twice as many. So instead of having instead of cutting 256 in half and in half again, that's 64 and then half again, should probably only cut it in half twice. So we're going to be a /25, /26. It's a /26 gateway. If you use the Cider templates, if we basically pull up our Cider templates, which I hope you've downloaded, and let's see, here's our /26. Eventually, what we're seeing here is that I want to zoom in a little bit. So we have a /24. We're going to move to a /26 so that we have 64. If we had 30, we'd have just enough for what we need, but we wouldn't have enough for growth. Now let's look at the address. The address is a 147 address. So originally the network was 27.143.22.0. But we have a 147 host address. If we look, 147 falls between the first usable address and the last usable address in network 3. That's this range, which means our network ID needs to be 128, our broadcast needs to be 191, and it's a /26 for a subnet mask. That's what we have. Our network ID is a 128, and our gateway address is one more than that, 129, and our broadcast is 159. Let's check that broadcast. Needs to be 191, so there isn't any broadcast address that matches that. So actually, this is the correct answer. Not sure why that's the case. I'm going to rescore this. I will change the answer to this item, and that will rescore everybody's assessment, and 4 students will have that correct. So let's do that right now. This one reads Cider Solution B. The broadcast address should be this one. This is our answer right here. So that's what we want. I'm going to edit this. We're going to choose this answer. We're going to submit and update attempts. So that'll rescore things. So now, if we go back, there would be some slight changes in the overall average for the course, but not very many. Actually, 6 students will get this incorrect, as opposed to 5 students getting it correct. So there'll be a trade-off of 1 student. So that won't make a big difference in terms of the average. In any case, that's one reason to use the templates, is that you can easily pick out what the answer should be. Let's keep going. We can close this template. What is wrong? Question mark. It's multiple choice. You are implementing IPv6 on a new network to ensure users are not limited while using traditional older IPv4 networks. So you were using IPv4, which were limited, and you don't want them to be limited now. A copier was set up by a new inexperienced network tech with the intention that anyone at different locations on the global and or organization network could print to the equipment. What we're saying is that you have a global organization and it has many sites, and you want everybody to be able to print to this. Copier toner is much less than printer ink and toner. The address assigned to the copier is FE80. This is a local link address. It's going to be accessible only on the local network and not to other subnets within the global organization. That's the problem. What is the most likely cause this dysfunction and most practical? This is a local link address. Assign one with a global network prefix. Now, the fact that it's a unicast is already a given. So that is a unicast address. Assigning one that's an anycast isn't going to solve the problem. Assigning an address that's a multicast isn't going to solve the problem. Multicast is used for streaming media when the source is live. Unicast is when it's on demand. Use of the broadcast address, that's not good, because anytime anybody prints, it's going to be broadcasting to everybody. So, let's see, bad router, not. So, a student who is new to the configuration of Cisco routers has set up and saved the initial configuration. Once again, he or she has set up and saved the initial configuration of the Ethernet interfaces and basic routes between networks on an important router. However, after a time, network traffic passing through the router between adjacent networks simply stops randomly for what appears to be no reason at all. Select the most likely culprit of this symptom based on the scenario provided. The student neglected to include the no-shut command. So even though the setting was saved, it was saved without the no-shut option being in the mix, which meant that the interface is going to shut down. So this is kind of a holdover from days when internet and wide area network connections were terribly expensive. So if there was no activity or after a time interval, the interface would shut down automatically. So saving the configuration again isn't going to help. It's already been saved. It's missing something. Using a proper subnet mask for the interface or the route configured isn't going to help, because it works. If the improper subnet mask were used, it wouldn't work at all. most likely. And some of you experienced this in your solutions. You had a different subnet mask and nothing worked. Cider solution A. Choose the best answer statement from those listed below. You're provided with the following IP address and a subnet mask for a network. Here we go again. For all sorts of reasons, the IP address cannot be changed. The existing network must be enhanced using a Cider solution to reduce the number of network clients to roughly 1/2 the original network. So that means we're going to be using a /25. We're increasing the number of ones by 1, sliding the mask one place to the right. That's going to cut our network in half. Using the appropriate template, provide the network ID, gateway, and broadcast address. Well, if I remember correctly, it's going to be a 128/25 network ID. The gateway is going to be 129 and the broadcast is going to be 255. Let's check. I'm sitting on 147. Let's look at our /25. $147 doesn't fit between 2 and 126. It fits here in network 2, where my network ID is 128, the gateway is 129, and the broadcast is 255. We'll keep going a little further until we get to here. The company knows that the sale of one of their divisions to another company will greatly reduce the size of their company. So they're selling part of their company to someone else. Only 1/4 the number of network addresses will be needed. They use a Class B address range with a /16 subnet. A decision is used to use Cider to scale down efficiently. No further growth will need to be considered. How many places and in which direction should the company slide the 1's value in the subnet mask? Well, if we're cutting it in half, we're going to slide it one place to the right, which means we're going to have a /17 address. Oh no, it's 1/4. It's not 1/2. That's 2 places to the right. So instead of a /16, that's a /18. That's the answer. Sliding it one place to the right would cut it in half. Sliding it 2 places to the left would double and then quadruple the size. Sliding it one place to the left would create a /. It would double the number of addresses, not cut it to 1/4. Local only connectivity. You are required to resolve a problem where only certain clients cannot communicate or connect with any system outside the local network. Other hosts on the same network have no trouble doing this. So there's a clue, meaning, okay, if the other hosts can do this, it's not that you have a gateway router problem, but the clients may not have a gateway address specified. So ensure a proper gateway address is configured on the client interfaces. What would you recommend to resolve this matter? If you configured the clients using a public address, that doesn't explain why some hosts on the network work and others don't. If you configure a smaller subnet mask to expand the network, That's not going to solve the problem because some of the hosts can still talk. It doesn't say whether that's only hosts in a certain range, a portion of the range. It just says other hosts. A new service provider has set up different local area networks in each building of a neighborhood for better security using managed layer 2 switches. However, no one can ping from any system in one building to the server in another network in an adjacent building. The provider has verified each of the switches are properly connected to each other. Which action will resolve this issue? Okay, well, what we're saying is that if you remember your Net Academy SmartNet, your packet tracer, it's kind of like the routed solution that we did for the module solution. So we had to set up a router to configure a proper gateway address for each LAN, and we had to have a static route. If you were missing either the gateway address on the router or you were missing a static route on the router, you couldn't ping something in the next neighborhood. That's literally the solution we performed. Headers during transport. During transport between networks, a router changes the headers on data passed to the next network. Choose the best answer statement from those listed below. The header of each frame is changed for layer 2 transport, but the IP headers do not change. They remain the same. In other words, the payload inside the frame is a packet, and the packet has source and destination IP addresses in the header. So, that's the answer. All the other answers are bogus. The one answer that a router decides if a frame is part of the local network based on the ARP table for routing decisions. Yeah, no, it's the IP address that makes the difference. It's not the MAC address in the ARP table. A router works on layer 3. It uses IP addresses. The router doesn't decide based on the ARP table. It decides based on the IP address of the packet that it receives. IPv access to resources, Part A. You are a programmer who must update your code to ensure a new website. Oh, now we're dealing with square brackets. Can be accessed using the new IPv6 address. That's the answer. We're not using colons in addresses. We're using dashes. There you have it. True/false, IPv6 Essentials, Part 2. The new version of the IP protocol uses the subnet mask. No, that's incorrect. The new version of the IP protocol, it uses subnets, meaning smaller networks, but it doesn't use a mask. It doesn't use a subnet mask to distinguish between global and local network assignments. So the statement that reads, the new version of the IP protocol uses the subnet mask, that's false. It uses subnets. What manner of activity? Some network utilities are used to analyze the traffic from a number of connected devices on a private IP network. As they transmit data to and from online resources, it is clear that all of them are using the same public IP address. If they're all using the same single public IP address, that's port address translation. However, they all have unique port numbers, and no two devices have the same port number, even when the same device is used for different connections and apps. What does this pattern most likely reflect? Port address translation, not dynamic NAT. That would be a pool of public addresses. And basically, static, that would be a one-to-one public to private. There are no ports involved with either dynamic or static. So that's another thing to remember. If a port is involved with the translation of IP addresses, that's port address translation. A misconfigured firewall is the likely involvement of malicious actors? No. No. No, we're not talking about a problem. We're talking about the pattern on the network, but it's not a malicious pattern. Let's see. This we'll skip. Most everyone got this correct. Oh, what the heck. We'll look at it. One nice innovation of IPv6 is that it does not use DHCP for automatic address assignment. That is true. Most students got that one correct. But a few missed it. So we'll go over the multiple answer here. Which specifications apply? You are directed to configure the connections between many segmented networks used by a number of organizations that must work together. So we're not talking about subnets in the same organization, we're talking about different organizations. The network design must be robust so that a single point of failure does not result in an unusable network. So if we had routers between those organizations and we use static routes, if one of them broke, that might create a problem. So we need something that's dynamic. Should failures occur, it is very important that packets take an alternate route and they do so in a manner with the greatest efficiency. That means they have to look for the shortest path. Select the options below that would serve to accomplish this goal. RIP is dynamic. A single point in failure. So it says should failures occur. You don't want a single point in failure. That's what Border Gate Protocol does. BGP. You can have different internet service providers at a given site, and those routers are designed to fail over. In case one of them drops, the other two pick up. That's what BGP does. RIP is the routing protocol that's dynamic and automatic. Open shortest path first, OSPF, is what you're looking for. PIPA and ARP don't have anything to do with this. And that's it. This concludes our item analysis of the Module 3 assessment. After you reconcile your errors, good luck with your final attempt of the Module 3 assessment.